we have Matthew Ayres, who is coming to us from Dartmouth College, and they will be talking about forest pests. So I'm going to turn it over to Matthew Ayres to kick us off in this range shifters and sleeper species session.
Thank you very much, Emily. It's nice to be here and feel all this positive energy from the RISCC growth. I'll talk about a few topics within the broader category of forest pests and their management in the Anthropocene. There are many people who've contributed to this. I've done almost nothing, but I'll draw a fair amount from a paper by the same name by myself and my good colleague Maria Lombardero. So I have to begin by talking about the southern pine beetle, Dendroctonus frontalis. It does damage like this in the southern pine forests of the US. It's a native species. It's been doing stuff like this since long before there were people watching it. It has naturally explosive population dynamics. It's arguably one of the most aggressive tree-killing insects in the world. So that patch of trees you see there, we call these spots because of how they appear from a small airplane, began just weeks before this, when a few beetles and then thousands and then tens of thousands of them converged on this area with the aid of pheromone plumes and began attacking these trees in the center. And this photo is taken midsummer, just a few months after it started. And there can be thousands of such spots, say, within one national forest in 1 year. In other times and places, they're so rare you can't find any of them. So this is the distribution of southern pine beetle on the right there as it was reported in the 1960s. In practice in the US, almost all of the action is in the lower tier of states there. Those upper states are places where, a few had been found. So it extended the range map, but they were absent or very uncommon most of the time. We asked the question, beginning way back in the 1990s, of why is it the southern pine beetle? Why doesn't it occur farther north than it does? And so candidate hypotheses included host trees, weather, which can include a lot of things, dispersal limitations, natural enemies, and we have evaluated all of those in various ways. This is some more detail on how we evaluated the potential importance of winter cold temperatures. So this is a data measurement from a single southern pine beetle. We've done thousands and thousands of these. Take a single pine beetle, attach a tiny thermocouple to it, dangle it inside an Erlenmeyer flask, put the flask inside a temperature-controlled water bath that we can program so that the temperature will decline. That's what you see with the line going down here. That's the temperature of the beetle going down with the temperature of the water bath. And as we watch the path, we see a place where there's a spike in the temperature. So this is the moment when the poor beetle went from being alive to dead. That's an exotherm, the heat of fusion from when the liquids in the beetle suddenly turn to ice. And that's the energy that's released from it. So it gives us a tool for measuring it. So we can refer to this as the supercooling point, the temperature at which it freezes In this case, it was about minus 12 degrees Celsius for southern pine beetles and many other insects. This is also the lower lethal temperature. So if we take beetles down to just above that point, hold them there for days or weeks, they're fine. If we take it just beyond that point, bring them right back, they're still dead. So it's the lower lethal temperature. And we can take many measurements of those and describe the population. So this is one way of doing it. This is the proportion of individuals dead as a function of the minimum temperature. So some of them begin freezing before minus 10, and maybe 90% of them are frozen by the time they get to minus 15 degrees Celsius. So we were able to get very good information, we think, on this physiological response characterizing the lower lethal temperature. So, you know, the weather to physiology part of this we have nailed. But does that relate to population dynamics in nature? Of course, there are lots of other things going on in these populations, and it might or might not be consequential for patterns of abundance in space and time. So we tested this by first beginning with this physiological prediction. So this is from all of those measurements in the laboratory. We've expressed this here as the probability of not freezing. So it's 1 here. So this indicates that, you know, until you get to about minus 10 or so, they're all alive, and then they decrease here. So this is the physiological prediction. Then we had abundance data, replicated time series of abundance from this network of cooperators in the Southeast, led and organized by Ron Billings for many years. And each spring, cooperators would deploy a few of these funnel traps baited with a pheromone, fronolin, that's attractive to the southern pine beetles, and see how many beetles they catch. So the size of the dots that you're seeing there, that's changing every year, reflects the number of captures of beetles in those traps. So at each of those locations, we have a measure of how many beetles there were last year, how many beetles there are the next year, and we wanted to relate that to how cold it got in the winter before. So those triangles are all of the places where we have beetle measurements, and the dots are all NOAA, NCDC weather stations with free, publicly available, high-quality data on daily maximum and minimum temperatures. We extracted from those stations the coldest night of the winter, and then we could interpolate between the weather stations to the forests where we have measurements of the beetle. This map just shows 1 year that changes every year. So now, based on that map and the time series data, we can drop the points down from that, and this is what they look like. So this is based on almost 1,500 interannual population growth rates. It's about 20 to 50 locations times 5 to 12 years. So these are aggregated into bins here to make it easier to see. And you know, as ecology goes, this is a pretty good fit between the theoretical prediction from the physiology and the empirical data. So we can see that until temperatures get to about minus 10, the best estimate of beetles next year is that there'll be about as many as this year. But then as you get colder than that, we expect fewer and fewer the next year. So this gave us some confidence that we were onto something, and that this actually translates into abundance in nature. Not too long after we were doing this work, it became newsworthy that the southern pine beetles had expanded into the New Jersey pine lands. So this aerial photo shows trees all killed in the last few months before the photo was taken. These are pitch pines. This is the largest, and the New Jersey pine lands is the largest remaining tract of the pitch pine forests in North America or anywhere. And the New Jersey pine lands are a notable place. Who knew that between the New Jersey Turnpike and the Jersey Shore, there's this, huge, beautiful forest. So over the next years, first the southern pine beetle was detected down here in near Cape May. It expanded its distribution, soon reached north of the Mullica River, and then in 2015, some of us were contacted by a federal employee down here who said, geez, what's going on with my trees? And we were able to say, congratulations, you too now have southern pine beetles. So it's absolutely ravaging the pine forests of Long Island. The pine forests of Long Island are at great risk of no longer being pine forests. And these are pheromone results from pheromone traps run by Kevin Dodds. And the blue triangles are places where they didn't catch any. Of course, you're not going to catch any in Maine or New Hampshire. But look at these positives. This is 90 minutes south of me or less. I used to drive 3 days to go to Louisiana and Mississippi to study southern pine beetles, and now they are literally in my backyard. So this is most definitely a range expansion, and this is why it's happening, or is at least a critical requirement for it to happen. So here are data for 50 years, 60 years, from 2 NOAA stations in New Jersey on the southern and northern edge of the New Jersey pine lands. And this is the coldest night of the winter. And you can see that over this 50 to 60 year time frame, the coldest night of the winter has warmed by 6 to 8 degrees Fahrenheit. This is enormous on the ecological scale. At the same time, the average temperature at these same stations with these same data, the average annual temperature has increased less than a degree Fahrenheit. And see these bands down here? So this is the band of temperatures where southern pine beetles die from freezing. So maybe 50% mortality here, 90% mortality there. And so look at the years previous to 2000. Probably it wasn't unusual in decades past for southern pine beetles to make it to the New Jersey pine lands, some from, say, Virginia. But there wouldn't be more than a year or two before any that were there would die. And we don't have winters like that anymore. So the climate, the warming of the coldest night of the winter. So way back in 2000, when people were just starting to think much about climate change, and it seemed like something that was off in the distant future, we hypothesized based on our physiological measurements and some climate analyses that suppose the coldest night of the winter increases by about 3 degrees C. We could estimate, well, then southern pine beetles, we would predict, could extend their distribution about 170 kilometers north of where they presently occur. So Dodds et al. Recently estimated that it's been about 200 kilometers northward. So the part that we didn't get right is that we didn't anticipate how fast winter temperatures were going to be changing. Remember this, the polar vortex of 2014. This was a front page story in the New York Times. Insect experts see a chance to kill off invasive species. So I got contacted by the New Jersey Forest Service after that, saying, wow, this is great. Does this mean that all of our southern pine beetles are dead? And we said, well, we have an app for that. So it's a real simple app. You can put a picture of this on your phone and pretend it's a phone app if you want. So this is how cold it gets in Celsius or Fahrenheit. And this is the expected proportion of beetles dying at those temperatures. So on that night, depending on where you were in the pine lands, temperatures got to -3 to +3 Fahrenheit. And based on that, we might expect that maybe 50% of them would have died. So we reported that to New Jersey Forest Service and said, no, we don't think they're gone, but now would be a really good time for you to try and exert suppression efforts on them because you're getting some help from the weather. So this is what actually happened. These colors don't mean anything. This comes from the New Jersey Forest Service, but this is acres killed by southern pine beetle, which is a decent measure of how many southern pine beetles there are. This is the number of acres killed in 2014, the number of acres killed after the polar vortex. So in fact, it went down by about a half. We weren't far off. And perhaps Jess Cancelliere is out there in the audience. Hi, Jess, if you are. This is her. She's been doing work on Long Island that included over quite a few winters measuring temperatures inside the bark of pine trees and doing samples of beetles during the winter to see how many of them are dead. And these events don't happen very often there anymore, but there was an event where it got down to -19 Celsius. And indeed, right after that, there were lots of dead beetles in her samples. So there's a few lines of evidence that give us pretty good confidence. In fact, I would say that our understanding of how weather and climate influences the distribution limits of southern pine beetle is really pretty good on a global scale because it's an insect that so many people have been studying for so long. We're just lucky to have that knowledge for one of these. The cooling or the warming of the coldest night of the winter appears to be very general. These are data from the Western U.S. And that's very similar to what we've seen in the East. So this is a real thing, warming of the coldest night of the winter. And I was very happy a couple of years ago to see this work come out from some very good climate change modeling people at Columbia University. And they produced for the first time projections from general circulation models of the coldest night of the winter. So that seemed to a climatologist, that seems like a very capricious metric, but from ecological standpoints, it seems very important. So their projections, the median projection and their ensemble of predictions, it was a warming of about 10 degrees Fahrenheit in the next 50 years. So add that to the warming of 7 degrees Fahrenheit in the last 50 years. This is 17 degrees Fahrenheit warmer on the coldest night of the winter. This is profoundly consequential for ecological systems. The southern pine beetle is not the biggest part of this story. We can reasonably expect there are going to be lots and lots of species entering ecosystems of the northeastern U.S. over the coming years as a result of this. You guys surely know the USDA plant hardiness zone maps. Well, these keep getting updated. These are based almost entirely also on the coldest night of the winter. There's for lots of plants and lots of animals, the coldest night of the winter is a very meaningful attribute. So tick and mosquitoes, ticks have been extending their distributions north. Mosquitoes have been. Are these things due to warming of winter temperatures? Well, it'll take study, but it's certainly plausible that a bunch of these things are. So one thing that can help with forest management in a rapidly changing world, the Anthropocene, is improved capacity to offer predictions that have value for forest managers. So I'm happy to be part of the development of a southern pine beetle prediction system, spbpredict.com. This has been supported by the Forest Service. The contributors are illustrated there. There's a screenshot. So this takes advantage of those trapping data, which continue to be done, as well as measurements of, well, how many spots were there in this forest last year, and a couple other things to generate predictions for all the participants, usually at the county or ranger district scale, of, for example, the probability of more than 50 spots, which is enough so that, if they're having that many beetle spots there, that's all the poor forest managers are working on that year. So it's working pretty well. The reliability of this is pretty good. And it's a little early in the day to show you equations like this. But the point is that a nice feature of this is that every year we get a new set of predictions and a new set of outcomes. So the data continue to grow, and we can continue to refine and update and improve the model with every year that goes by. So sleeper species, this is a transition. European wood wasp, Syrex noctilio. Is it a sleeper species in North America? Nah, I don't think so. Flora here has just published a nice paper in Forest Ecology and Management. There's more stuff coming out. She was able to do elegant intercontinental comparisons of the impacts of Syrex noctilio, including in Argentina, South Africa, Spain, and the US, and all over the world. It's largely restricted to highly dense stands of pine that have lots of suppressed trees. And in the Southern Hemisphere, there are lots and lots of places like that. That's how they grow pine trees there. In Spain and Europe, where it's from, it's inconsequential as a pest, at least partly because they don't have very many such stands. Nor do we in North America. So I don't think this is going to be a sleeper species. But there are more pests coming all the time. Congratulations to New York State for being a globally notable hotspot for a number of non-native forest pests in the world. So our forests are being reached by many, many new species, some of which could be the next emerald ash borer, high impact invasive species. So this is a project led by Angela Mack at the University of Maine, working group that very high functioning working group, I would say. This nice paper came out and the group did an analysis of what were the attributes that best explained those species of conifer feeding insects, non-native insects in North America, the subset of those that turn out to be high impact. And a punchline of this is that evolutionary history matters even more than we thought. For example, the high impact species or high impact invasions tend to be cases where the native host of the non-native insect is related to by 10 to 15 million years to a North American host species. So that seems to be close enough related so that the insect is likely to recognize it. It knows just how to feed on it. But it's not so close that North American host has adequate defenses. So evolutionary history is a predictor of which species can be high impact. So this is work we hope will be coming out soon, led by Dan Uden here. The columns of this are potential new invasive insect species. So candidates to reach North America that aren't here there. And the rows are North American conifer species. You can see a phylogeny species names here. And then the colors reflect the predicted risks. So look at these clusters of red. It's very, very non-random. So I think we can begin to predict those examples where, boy, this would be bad business to get these sap-sucking insects here on this clade of spruce trees in North America. So some of you might know about Matsukakus matsumori, the red pine scale insect. These are red pines killed over a few years in Massachusetts. This is from Asia. Its natural hosts are separated by 5 or 10 million years from red pine. This thing kills red pines dead. This thing is scary. Fortunately, it doesn't have wings. It was introduced in the 1929 World Fair in New York, people think. It still hasn't gotten very far. But think of the red pine forests in the Great Lakes states. If this thing gets there, it's gonna be a disaster. And you can buy things like Japanese black pine, which is a good host for this, through Amazon, free shipping with orders over $100, delivered to your door in New York or Wisconsin or wherever you want. This is extremely dangerous. It's only a matter of time before some of those scale insects make it to the center of red pine forests in the Great Lakes states. This is a soluble problem, but right now, nobody is working on this. I'd just like to point you to my colleagues at the Carey Institute who are working on developing their new national governance. Reducing the onslaught of non-native species can't be solved by New York State or Rhode Island or Wyoming. It takes some national governance, changes in national governments. We know how these things come into the country. They come in wooden pallets and live plant products. This can be reduced, but it's going to take new laws. and I invite any of you to try and help with that. So that's it. Thank you.
Thank you so much for that great talk. We have time for maybe one question if somebody has any questions ready to go in the Q&A box. And if something doesn't come in relatively quickly, we're gonna move forward. Okay, so our first question here is, so how do temperatures within a tree vary from the exterior of the environment?
Good question. We had to study that pretty carefully. They're buffered by 1 to 3 degrees Celsius, depending upon the size of the tree. And so our models take into account that thermal buffering that goes on in the trees.